Hi everyone, in this video we're going to be talking about the distance formula, which helps you find the distance between two coordinates on a coordinate plane. And the distance formula comes from the Pythagorean theorem. So to refresh your memory, the Pythagorean theorem is when we have a right triangle, okay, kind of like this. We have two legs, A and B, and we have a hypotenuse, C, that's across opposite from the right angle. The Pythagorean theorem tells us that A squared plus B squared is equal to C squared. So we can square the distance or the length of each of these two legs, and that sum, when you add them together, is equal to the hypotenuse squared. And in our last lesson and our last practice, we were using the Pythagorean theorem to find either missing legs or missing hypotenuses from right triangles. Now, we can use this same idea whenever we're trying to find the distance between 2 points on a coordinate plane. So if we scroll down on our screen here to a coordinate plane, I'm going to put 2 points on this coordinate plane. I'm going to put one right, oh, that wasn't my pen. I'm going to put one right here, and I'm going to put one right here. If we were trying to find the distance between these 2 points, let's take a look. This top point is at 1, 2, 3, 4, 4, comma, 1, 2, 3, 4, 5. So this one's at the point 4, comma 5, and this one down here is at the point -3, comma -2. And we want to know the distance between these 2 points. Now, what's nice about a coordinate plane is we usually can just count the different units based on the boxes. But in this case, you can't count units diagonally. So since this is a diagonal line, we need to find some other method to figure out its distance. And what's nice about a coordinate plane is we have all of these lines that are perpendicular to each other, which means that we can draw our own right triangle. Does everybody see what I did there? I drew my own right triangle, a little sloppy. The blue line makes a right triangle with the red line. Here's our right angle, right? So one way that I could use the Pythagorean theorem to find the length of this line is I could just count units for my run A and my run B, and then use the my leg A and my leg B to calculate the hypotenuse, which is our red line, C. So let's count these units. I have 1, 2, 3, 4, 5, 6, 7. So this is 7 units for this leg. And then I have 1, 2, 3, 4, 5, 6, 7. 7 units for this leg. And the Pythagorean theorem would tell us that 7 squared plus 7 squared is equal to C squared. 7 squared is 49. 7 times 7, right, is 49. So I have 49 plus 49 is equal to C squared. 49 plus 49 is 98. So I now have 98 is equal to C squared. And to find C, I can take the square root of both sides, and I get C is equal to the square root of 98. And if I put that into a calculator, I get about 9.9. So I'm going to use the approximately squiggly equal sign here. So this line is approximately 9.9 units long. And we found that by using the Pythagorean theorem. We created a right triangle out of this coordinate plane. Okay, let's take a look at another one. So let's put a dot right here. Oops. Let me fix that. All right, let's put a dot right here, and let's put a dot right here. And we're going to find the distance between these 2 points. Well, remember what we need to do is we need to draw ourselves a right triangle. So I'm going to take the horizontal distance between these points, and I'm going to take the vertical distance between these points, and then I'm going to count units to find the distances on each of these legs. So 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, now I'm just using a squared plus b squared equals c squared, where a and b are my legs. So I have, let's move so we have a little bit more space. I have 4 squared, so that's a squared, plus b squared, which is 12 squared, is equal to c squared. 4 squared is 4 times 4, which is 16, plus 12 squared is 12 times 12, which is 144, and that's equal to c squared. If I add 144 to 16, I get 160 equals c squared. And then I can take the square root of both sides to get c by itself. So the square root of 160 will be the length of our hypotenuse here between our 2 coordinates. And the square root of 160 is about 12.65. Again, I'll use my squiggly equals sign. Because some of these are going to be irrational roots. But we can see here how we use the Pythagorean theorem to find the distance between these 2 points. Now, we actually don't always need to use the coordinate plane like this. We can actually, just by using coordinates, listed coordinates, we can figure the same information. So in this case, let's actually write in what the coordinates were on this one. So this top point is at 1, 1, 2, 3, 4, 5, 6. So it's at 1, 6. And this one down here is at negative 1, 2, 3, negative 1, 2, 3, 4, 5, 6. And we want to know where, sorry, this is a negative 6. We want to know where this 12 comes from based at looking at the coordinates. Well, what 12 is it's just the difference in the y values. The vertical distance is the difference in the y values. So my y values are 6 and negative 6. And if I were to subtract those, 6 minus negative 6, remember when we're subtracting a negative, we're really adding, and that's where my 12 comes from. Let's see where my 4 comes from. For my 4, if I were to take my x value, 1, and subtract my other x value, negative 3, 1 minus negative 3, well, that's really like adding, and we get 4. So really all this is it's my y2 minus my y1, and we're squaring that, and we're adding that to, let me do some erasing here, we're adding that to our x2. Sorry, I'm not sure yellow is the best color to choose here, but I'm going to stick with it. We're adding x2 minus x1 and squaring that. And that's all equal to our distance of our line D squared. So this is like, if I were to write the Pythagorean theorem underneath this, I'll do it in red. This is like c squared is equal to a squared plus b squared. C squared is our distance squared. Our vertical distance squared, y2 minus y1 squared, is our a squared. And I'll switch to, let's do black on this one. So then my difference in x values, so my x2 minus x1 squared, is my other leg, b squared. So all this is it's the Pythagorean theorem using coordinates. Now we could go even one step further, and we could make if we were to take the square root of each of these sides, we've now gotten rid of this squared. So our distance formula could be that the distance d is equal to the square root of y2 minus y1 squared plus x2 minus x1 squared. This is just writing the Pythagorean theorem in a different, more user-friendly way that we can plug coordinates straight into and get a distance. So if we want to use this distance formula, here, all we need to do is have an x and a y and another x and a y. So let's try that once. Let's zoom out and get a little space here. So let's say that we had the coordinates -4, 7 and 3, 2. And I want to know the distance between these 2 points. Well, the first thing I'm going to do is I need to identify my x's and y's. So coordinates are always written x, y, x, y. And we can call these ones here our first points are x1 and our y1, and these are x2 and our y2. And then from there, we're just plugging these values into this distance formula. So d is equal to the square root of y2, which is 2, minus y1, which is 7, and we're squaring that. And then that's being added to x2, which is 3, minus x1, which is -4. So -4 squared. That's our whole distance formula there. Now we're going to work this out. So d is equal to the square root of 2 minus 7 is 5, so 5 squared, plus 3 minus -4. Well, that's really like adding them, so 7 squared. Now I can go d is equal to the square root of 25 plus 49, because 5 squared is 25, 7 squared is 49. And now I'm going to add together 25 and 49, and I get d is equal to the square root of 74. Now the square root of 74, I'm going to hit that into a calculator, and I get that d is about equal to 8.6. And that's how you use the distance formula with coordinates. Now, if this is hard for you to remember right here, that's okay. If you remember the Pythagorean theorem and you can do what we did up here without needing to write it out in this way, if you can just sort of sketch this on a coordinate plane, that's great. Or if you can just use the coordinates, if you could look at 2 coordinates and figure, okay, the difference between my x's and the difference between my y's are going to be my 2 legs, you can sort of take those and plug them into the Pythagorean theorem, and you'll be able to get a correct answer. But if you can just remember this is a really user-friendly way of finding the distance between any 2 points on a coordinate plane. All right, I'm going to keep this video nice and short, and I'll end it there. As always, please make sure that you're reaching out if you have any questions. And I'm going to turn you loose to work on your practice of using the distance formula and using Pythagorean theorem to solve for the distance between 2 points on a coordinate plane.